Progress. All right. So if I quickly summarize, we have done under chapter 10 electricity lesson. First we discussed domestic electric circuit, the specifications and the main components of house wiring circuit, and the functions of each component. So you should know the order of connecting all these electrical components of the house wiring circuit, especially a overload circuit breaker. Then so that is also called main fuse, then electric meter, then isolator or the main switch. After isolator, RCCB or the trip switch, residual current circuit breaker. After that, MCBs or miniature circuit breakers or fuse box. Sometimes we call it distribution box or D board. So this all these three together call consumer unit. That means isolator, RCCB and all the MCBs together call consumer unit. And from MCBs, or electricity is distributed to the sub circuits or the branch circuits which contain sockets and lamps. So that's what we discussed, and then I told 3-pin plugs, 2-pin plugs, then earth wire, the importance. So all this we discussed last week, right? So today we will start the last part of this, the summary of this. I'll share the screen now. All right. So next week most probably if I have time today, I'll try to start this today itself, or if not, at least by next week you have to keep this on hard copy ready, the printout if possible. Electronics we can start, right? So most probably from next week, because 10th lesson, right? Now this is where we stop. Page number 4, the last part, house wiring circuit. So this is the entire diagram, the house wiring circuit, the order of connecting. So again, you can 1, 2, 3, 4, 1 numbers, you have to label them. Right. So let's see number 1 here. So that is, so it's connected to the live wire. That is actually the main fuse or the overload circuit breaker. Right? Overload circuit breaker. After that, you have electric meter. So complete here the blanks of this flow diagram. Number 1, please complete your theoretic now. Those who have got the printout, you can complete. Right. If you have no space to write on this inside this sketch, you can write it separately. So number 1, overload circuit breaker. Overload circuit breaker. Sometimes we call it main fuse. Main fuse. So please complete overload circuit breaker. What is the first component? Overload circuit breaker. Second, number 2. So important, this live wires pass through, only live wires pass through the overload circuit breaker. Number 2, that is the property of electricity board, electric meter. Number 2, electric meter. Sometimes they can give the same diagram in the exam and ask questions, right? Electric meter, that is a property of the electricity board. Number 3, after electric meter, the next component. So both live and neutral wires pass through this, that is isolator. What is called isolator. If you want to write within bracket, that is also called the main switch, isolator. After isolator, the next component, RCCB. What is RCCB? RCCB stands for residual current circuit breaker, or sometimes we call it trip switch. So within bracket you can write trip switch. So you can see there's a dotted line here, this box X. So this dotted line encircle by a dotted line all 3. So what is encircled by this dotted line? What are the 3 sections? MCB, isolator and RCCB, or we call it D board, distribution box. So if you want, I'll put 1, 2, 3. So number 1, isolator. Number 2, the trip switch or the RCCB, and number 3, this distribution box or the D board. So all these 3 together known as consumer unit. So what is X here? Consumer unit. Consumer unit. You have all this in your house. You can check. Consumer unit consists of, if you want to write separately, consumer unit consists of isolator, RCCB and distribution box. So inside the distribution box there are MCBs. Inside the distribution box there are MCBs. What is MCB? MCB means miniature circuit breaker. So those are the main components. Now you can see from this L1, L2, L3, L4, L5, from this D board, or sometimes we call it distribution box. So we call it D board. Sometimes we call it fuse box, D board or distribution box. So all these same component. So D board or distribution box, there are various fuses of different ampere value, so that distribute electricity to the sockets and the lamps. So you can write MCB. So please write, if you have space here, MCBs of the D board or distribution box distribute electricity to the branch circuits. MCBs of distribution box. So from the word itself you can understand a distribution box, it distributes electricity. Distribute, please write this everyone below this same page at the bottom or separately. Distribute electricity to the sockets and lamps. SOCKET. Sockets means plug points, and lamps or lamp circuits. So you can write this separately at the bottom separately. So MCB MCBs of the distribution box distribute electricity to the branch circuits, which consists sockets and lamps. Right, next one. Late comers, please hurry up, you have to join on time. So it's some of you are 10-15 minutes late. Don't make that as a habit. Right, anyone still copying down this? Anyone is still copying down this? Please raise the hand. Anyone still copying down this, because I will move down now. Please join with the correct name code. First you have to put your first name and then the code, because I am taking attendance. Right. Next one. So you can see there's an earth wire. So can you see this earth wire? If you can highlight this, what is the role of this earth wire? Whenever there's a leakage, this leakage current get earth through this earth wire. So it's ground. So then the trip goes off. So it's an trip indicates that there's a leakage from the main circuit. Sometimes you might have seen this physically. You might have seen this underground metal pipe. Outside of your house, there's an underground metal pipe. So electrician, before completing the house wiring, so he will attach a green colored wire. Sometimes you might have observed this. There's a green colored wire. So this is the earth. So this is the symbol. So this is the symbol we use for earthing. This is the symbol for earth wire. So earth wire, what is the standard color? Green. Right. But sometimes what happens, this in coastal area, this can get corroded. This underground metal pipe, this with the corrosion, what happens, this can get disconnected, this green cable or the wire. Then what happens when there's a leakage, even though the trip is working, so then there's a problem. So therefore, that is for your safety. That is for the safety of the consumers and the electrical appliances. Right. So let's move down. I'll erase this part. You had enough time to come down. Now you can see this is called, you can see this there's a red one. So the electricity available, if you only can mark this with your pencil or pen, or else better to mark with a red pen, because if you have got the printout then you can't see this clearly. Then from the live wire, electricity is pass to these switches. So you can see the switch is always used for the live wire. Switch is always used for the live wire. Current passes from this MCB to the live wire through the switch and then through the lamp. Number one, so this is called two-way switch. So you can on and off from any end. So staircase, before you climb the staircase, what you can switch on the lamp, and after that you can from the other end, opposite end, you can off it. Sometimes definitely you might have seen this in your house. The mostly if you have a staircase, you might have. So this is very, if you can put an arrow with the pencil, right? So this is very useful in when you're climbing the stairs, right, in your house. You can on the switch from one end and you can off it from the other end, or else if you are coming from the top, then you can on, and from the lower end you can off it, the lamps. Otherwise you will again go back to off it. So this is one-way switch. So there are two types of one-way and two-way. And can you please write, put an arrow towards this and write, the switches are always used for the live wire. This is very important. Any house, switches are used for what? Live wire. For the live wire. LIV, live wire. Not for the neutral side. So the opposite end then is current coming out. So that's a neutral wire. So this N, you can see a N means neutral. So it's return. So this is a neutral. So it's return to the neutral one. Right. So electricity is available through the live wire, and switch is always even in the plug point. Even in the plug point of the socket, so the switch should be used for the live wire. Can you see here? This is the switch for the plug point or the sockets. So I'll put an arrow here. This is the switch of the plug point or sockets. Even in plug point or the lamps, the switch is used before that. So from where the current is coming. So that is for the safety. Otherwise, what happens, even if you off it, and you can get electrocuted. So this is how it happens. Now can you see, this is one thing you have to notice. There's no earth wire. There's no earth wire for the lamps. So no earth wire for the lamps. But here you can see there's an earth wire for the plug point. So this is the earth wire. Can you please label this? This is the earth wire. This earth connection, this earth wire is available. So this is earth here. So it's available for the sockets, but not for the lamps. So you can write, if you want, electricity is supplied, only live and neutral wires are used for the lamps or lighting circuits. Lighting circuits we use only live and neutral, but not the earth wire, because daily you are not going to hang on this lamp, or you are not going to touch this like the electric iron, blender, grinder, washing machine, like that. You are not going to touch this ceiling fan and these lamps in your house, so you are not going to touch daily. So unless you are going to replace this lamp, you are not going to touch them frequently, and there's no metal outer covering the bulb. Therefore you can, whenever you want to replace the lamp, you can off the switch, and it's better to off from the main switch also before you replace the burn lamp. Therefore electricity is supplied to the lamps only only two wires for the lamp circuits, but plug points of the sockets, there are three wires. So what are the three wires? Live, neutral and earth. Any plug point, earth wire is available. Thick wire is earth wire, but if you want, you can use for the plug point 3-pin plug or 2-pin plug. Some plugs are 3-pin plugs, some plugs are 2-pin plugs. 3-pin plugs are safer than 2-pin, especially when you are using more electricity, like higher electricity consumption appliances with which consume more electricity. Then it's recommended to use 3-pin plugs with the earth wire, because when there's a leakage, the leakage current will be more, then there will be damage to the consumers. Therefore especially like air conditioner, so it will never become 2-pin plug. It's always 3-pin air conditioner, AC, right? So then if you take microwave, it will never become 2-pin plug. So it's 3-pin plug. The plug point anyway, 3-pin, so there are 3 holes, right? So those things very important. And please write it, for the lamp circuits or the lamps, only 2 wires. Electricity is supplied only through 2 wires, but sockets there are 3 wires, so including the earth wire. And this also, direction also very important. Live wire in this side, live wire right hand side, Neutral wire left side. That is also very important. Don't mix up this in the earth wire. It's easy to remember. The middle one is earth wire. Live right side, N left side. So sometimes they can give this in the exam and ask questions, right? Okay. What is the correct method of labeling this? Sometimes they can ask you to label this, right? So let's move down. Then the last one we call it ring circuit. So that means what? Imagine in your kitchen or maybe your dining area or the room. So you can have three plugs here. Here three plug points through this ring circuit. So ring circuit is very useful when connecting more than one plug point. Ring circuit is very useful when connecting more than one plug point, right? So that is about this summary of this. I'll move to the PowerPoint slide now. Okay, let me share the PowerPoint now. Right. You can see the screen now. Okay, let me explain this diagram. You can see the whole diagram now. You can see here 3-pin plug. So how it works? 3-pin plug. So when there's a especially 3-pin plugs are used for the electrical appliances with metal outer covering. 3-pin plugs are mostly used for the electrical appliances with metal outer covering. And there's a fuse also. Why fuse? When current go beyond the limit, the fuse go off, protecting the electrical appliance. If current go beyond the limit, some electrical appliances come with a fuse. Example, your laptop charger, there's a fuse. So that fuse protects the electrical appliance from high current or high voltage. Right. So then, so this is heating element. So here you can see, can you notice here, there's a earth wire from the outer covering. So this is the most important. I'll highlight this earth wire. So this earth wire, it is attached to the outer metal covering of the electrical appliance. So imagine now when you are going to haul this, if you are going to touch this, what happened? If there's a leakage, instead of passing the current through the consumer to the earth, so the leakage current, whenever there's a leakage, the leakage current get earth through the earth wire to the ground in your house, but not through the consumer. But if you don't use this earth wire, what happens? If you don't use this earth wire, the leakage current get earth. If you don't use this earth wire, the leakage current get earth through the consumer. Then you get electric U10. If you get electric U10 if there's a leakage from the heater, right, or the metal casing. So this is very important. If you want to write here electrical appliances with metal outer covering, so it's very important to use 3-pin plugs. Whenever there's a leakage, current get leaked through the metal outer covering to your through your body to the ground. That is for the safety. So next one. So these are the applications. So mostly you get the questions in the exam from these applications. So now remember, current flows from high voltage to low voltage. So it's live wire 240. Live wire 240, so the neutral 0 volt, like that. So ground 0 volt. So that's how it happens. When there's that is called potential difference. Potential difference. If there's no potential difference, so imagine 5 volts, 5 volts. So then current won't flow. So if you take 5 volts and 0 volts, then the voltage potential difference 5 volt. Difference 5 volt. If you take this end 5 volt and the other end 3 volts, what is the potential difference? 2 volts. So remember, to flow electric current, there must be a potential difference. If the potential difference is 0, there is no current flow. Imagine if you connect batteries this way, 2 batteries this way, plus plus together. This side plus, this side also plus. If you attach like this, what happens? Potential difference become 0. Then current won't flow. Remember always, to flow current, there must be a potential difference. So imagine to flow water from the tank to your sink or the bathroom, but there must be a pressure difference. So water flows from high pressure to low pressure. So same scenario, electricity from high potential to low potential. If there's no potential difference, current won't flow. So this is again a similar diagram what we discussed in the theory tube. You can see again the neutral. So live wire. Actually, this should be the neutral. Yeah, neutral wire. Black cable, neutral wire, and the red one live wire, so it is passed through the electric meter, but here they have not put the fuse actually. So after that you get main switch, then RCCB, all these components are available in your house. So this is the isolator, then the trip, and this dotted line represent distribution box, or the D board distribution box, MCB. So the electric meter is a property of electricity board. So this sort also you should know. Next one, again similar diagram, you can see there's a fuse. So this fuse, before electric meter there must be a fuse. Mostly this fuse 30 amperes, 30 to 40 amperes. If current exceed beyond the limit from the there's a black cable connected to your house from the electrical post, black cable. So that is called supply wire. This supply wire consists of two wires, what? Live wire and the neutral wire. Live wire, neutral. So then after that it passed to the electricity. So this is a digital one. Digital meter. Digital electric meter. So developed countries now in Sri Lanka also use digital meters or remote sensors, so they can monitor without coming to your house. They can calculate the electricity bill. And this is isolator. Here the name itself you can see isolator. So all this in the off position now. It's down means off. Right? It's lever down means off. Lever up means on. Right? So all this in the off position, or the circuit is open. So these are the MCBs. So each MCB has a fixed ampere value. So if it is 10 ampere MCB or 13 ampere MCB, so they distribute electricity to different branch circuits in your house. So you can get different line diagram in the exam, but remember they will never ask you to draw this entire diagram, never, but only for labeling. Now this one also downloaded from the internet, so everything that you download the internet not 100% accurate. So here they have put capital K, that is wrong. So it should be simple K. There are so you have to be careful when you download the images from the internet, right? Next one. So this is again, can you see the real physical appearance? Here, this is the electric meter. This is, you can see there's a fuse here, right? Okay. After that, so both these outside, externally installed. That means not outside the house. Outside of your house, both this electric meter and the overload circuit breaker. Because whenever, even though you are not at home, they come and disconnect the supply if you don't pay the electricity bill, as well as they can monitor the reading to calculate the electricity bill. So this is a traditional one. This disc rotate. So this disc rotate. So when you are using electricity, so this will rotate fast. When you are consuming more electricity, so this will rotate fast. So this is so this is correct. Simple K, capital W, simple H, kilowatt hours. So they will take the last month reading, say 3000, previous reading 3000, and the next reading 3100. Then they will, how many units consume? 100 kilowatt hours consumed for that month. Then they will calculate the electricity bill. So they will subtract the previous reading from the current reading and calculate the electricity bill. So that is manual one. So everything mentioned, definitely you should have electric meter now in your house. Without electricity meter, so you cannot consume electricity. That is illegal, right? So you can check whether these things are there, these kilowatt hours, and check the frequency, hertz. I mean, everything mentioned here. Frequency, single phase, so phase, three phase, this is single phase one. Or the voltage given. So where is 240? So it's given here 240. 50 hertz here, 50 hertz. So it's not that clear here. 50 hertz, 240. Please check in your house also these things, information. Then you will remember this easily, right? Okay. Now today this is what we are going to discuss. I'll ask a simple question. Okay, before that, let's move back to the, I'll come to this after completing the next part in the theoretic. Let's move back to the theoretic. Right. Okay. 3-pin plugs are safer than 2-pin plugs. Right. Why 3-pin plugs are safer than 2-pin when connecting appliances with metal outer covering? Metal cover. Whenever there's a metal cover, 3-pin plugs more suitable, safer. So what you should write here? 3-pin, I think last week also I remember I told this, 3-pin plug has earth wire. 3-pin plug has earth wire. When there's a leakage, the leakage current get through the earth wire but not through the consumer. When there's a leakage, leakage current. When there's a leakage, leakage current gets earth. Leakage current gets earth through the earth wire. This prevents the accidents caused due to the leakage current. This prevents the accidents caused due to the leakage current, or this protects the consumers from leakage current. This prevents the accidents due to the leakage current. This prevents the accidents due to the leakage current. Then the trip goes off. So whenever trip goes off, you should understand that there's a whenever trip goes there, you should understand that there's a leakage of electricity from the main circuit. But when you are using 2-pin plugs, so earth wire is not available. Then the leakage current get earth through your body to the ground. Then also the trip goes off. But then you get electrocuted. Using 2-pin plug or 3-pin plugs, you can get electricity, no problem. But the 3-pin plugs much safer. So especially when you have electric vehicle, so it consumes 15 amperes current. If you get few seconds 15 amperes current, you will die on the spot, right? So 15 amperes current electric vehicle, electric vehicle. So electric vehicle does not allow to, there's a circuit actually sensor. If you get current only from live and neutral to the electric vehicle for charging the battery, there's a sensor, it will not charge the battery. It does not allow to charge the battery only using 2-pin. So definitely you must have a earth wire, that is for the safety, because the entire vehicle, the body is metal. What happens when there's a small leakage of current from the battery to the metal body or the vehicle outer covering? So then you get electrocuted. That is very risky. Okay, so that is very, very important, earth wire. Next part. That is the last part of the lesson, power of energy or the rate of energy dissipation of electrical appliances. Okay, before I complete this last bit, now I am going to ask few questions from you. Right? This is the last part of the lesson, power and energy of electrical appliances. I'll move back to the PowerPoint slide now. Okay, you can see the screen now, the PowerPoint slide. Okay, now I am going to ask, when you are going to buy electrical appliances, okay, if you go to an electrical shop or the showroom to buy any of these components, what are the things you should ask from them before you buy any of this? Yes, who can tell me some information you should ask before you buy any electrical appliance? Yes, any volunteers? Yes, Randima, what are you going to ask from them before you buy? Yes, Randima, Arush,
What value?
What value?
Kavini?
Brand.
Brand. Okay, so actually earlier they told what value. Number 2, brand. Number 3, any other, anything else? Ash, that's it.
Whether it's a 3-pin or 2-pin plug.
3-pin or 2-pin. Okay, 3-pin or 2-pin, because then you should have a plug point in your house now. Okay, right? Okay, 3-pin or 2-pin, right?
Whether it is eco-friendly.
Eco-friendly, right? Eco-friendly. What else? Number 5. Yes, Lonita. Others, what about the others? Ochana, Shavindi, Tirani.
Warranty.
Quality, warranty. Okay, quality means what? Quality, there's a very broad one, right? So you have to be very specific. Right? Yes, Sandali, Devish.
Price.
Price, that is the first thing you ask. So nobody knows. So the price, you ask first price. That is the most important thing. price, whether there's a sale or whether there's a discount, whether it's a promotion. So those are the things you ask first, right? Price. Okay, what else? Anything else? Sandali, Devish, Randima?
Lifetime.
Input voltage.
Voltage. Okay, voltage. Lifetime in the sense. Okay, what is the durability, right? Or maybe durability, lifetime. Durability. How long you can use it? Average without breaking down. Anything else? Arosha, Randima? Yes? Is that all? Okay, out of this, actually, out of all these, people mostly they don't ask one of this. What is that? Mostly they ask most of this price and the brand and specification. They ask about everything, price, model, brand, the features. Yeah, what are the inside? What are the you compare everything, but you don't compare mostly one thing. Even though you gave the answer first to two of the students, they gave the answer, but mostly they don't. Your parents or most of the people I have never heard asking the one component here, one information. What is that?
What value?
What value they don't ask? Correct, very good. What value? So I don't know how many times we have asked this. What value when you buy something? Not in, not in the shops before you buy. After taking them home, maybe you are not going to buy them. So maybe your parents or someone else has brought this to your house. You never look at this. You ask, how much was this? So is this cheap? Is whether any discount you got, right? Whether you can pay installments, and is this, what are the other brands? So you ask everything, but you never check the watt value. Therefore, remember the most important thing, one of the very important information, not only the price, brand and the size, you should ask the watt value. Power, what is this called? What means power of the electrical appliance. Actually, they don't display this clearly. Most of the electrical appliances, they display the price and the name and the brand, but they don't display watt value or the power. It is somewhere at the bottom or underneath or the backside of this electrical appliance, a small tiny letters they print it. But if you ask from them what is the watt value, they don't know actually. Some of them they don't know. They will ask, wait, I'll ask from the manager or someone, and so the most of the showrooms, so they help us, they don't know. Therefore, let's see why this watt value is important. Okay, look at this. Look at the next one. Now, when you take this low watt value, why watt value is so important? Can you see here? You can see this 1000 watt here, 1000 watt. So it's printed here. Other than the voltage, as you said, frequency, made in where, and all this with this model, with all this barcode, with all this, they have put the watt value. We usually we don't ask this mostly we don't ask this watt value. We ask everything before you buy. We never ask the watt value. Very rarely, if someone is good in electricity or maybe electrician might ask, but normal. So in our daily life, we don't use this. Even after taking home, you don't check. So higher the watt value, higher the electricity consumption. So this is very important. You can check from which electrical appliance your electricity bill. Your electricity bill get affected more from which electrical appliance. You can check by looking at the watt value. So that one you have to be careful. You have to, when it's done, you have to off it immediately. Otherwise, you have to pay more for the electricity bill. Sometimes you ask whether it's cheap. So imagine you compare two appliances. So two different brands you compare, but you check only the initial price, initial cost. So imagine two refrigerators, but after taking home, it's cheap but high watt value. Cheap but high watt value. High watt value. Then what happened? Initial cost maybe 2000 3000 rupees low, but after buying this, lifetime, until it's breakdown or until you replace that, you have to pay more for the electricity bill. High watt value means your electricity bill goes up. Therefore, because you pay only once for the electrical appliance, but every month you are paying electricity bill for using this electrical appliance. That means watt value is very, very important. Don't compare only the price, brand and the other specifications only. You have to compare that also, but don't compare only that. Before you buy, at least you have to ask, at the end at least you have to ask what is the watt value of these two. Then only you can decide whether to buy which one. So I'll come a lot of other examples with this. Now you can see if you take air conditioner, so it consumes a lot of electricity. In your house, air AC not only 1 or 2 hours, sometimes 24 hours, or at least in office or banks, at least 8 to 10 hours it is operated, it is on 9 to 5. So because even though the bank closes at 3 o'clock, so they are working until about 6 7, so nearly 10 hours, at least 8 hours, at least 8 hours it's on, right? At least 8 hours AC in office. So others you don't washing machine you don't operate throughout the day until it is industrial or like commercial purpose. So refrigerator also the whole day it's on, the whole day 24 hours on. You don't off the refrigerator in your house, right? So if you off, then there's a problem. The meat items and the dairy products get rotten inside. Therefore, the actually refrigerator, the watt value is higher than that. When the size of the refrigerator increase, then also the watt value goes up. Sometimes what happen, only 3 members in the house, right? Only 3 members in the house, you buy big refrigerator, right? So maybe only 2 apples inside. You don't have, you don't store much fruits or vegetables inside the refrigerator, but you are paying more for the electricity bill, right? So therefore you have to select the correct, not only the price or those things, so you have to consider how many members in our house, so that the size of the instrument also very important. With the increase of the size of the refrigerator, the watt value goes up. The AC also, there are different BTU values, 12,000 BTU, 80,000 BTU, 24,000 BTU. With the increase of the BTU value, the watt value also goes up. Therefore you should have some, you should know how to compare this. Sometimes the exam they'll give different values. They'll ask which appliance consume more electricity. Okay, so therefore those appliances you have to off immediately. Imagine you are going to leave the office, so by 5 o'clock, then by 4:45 you can off the AC, right? Because that so you about 10-15 minutes, so that cooling sensation you get. So that's how you should operate this. So let's move on. Therefore always look at this. Now you can, after the class, or at least today or tomorrow, check each electrical appliance whether you can find the watt value, right? So refrigerator don't keep inside, because some electrical appliances are easy to handle. So then you can check microwave oven, then electric kettle, blender, grinder. So your laptop, everyone is using a laptop, so laptops or computer, so what is the watt value? So those things very important. Then you can decide which electrical appliance consume more electricity in your house, more electricity in your house. So especially actually out of all this, the electric iron, electric kettle consume more electricity, more electricity. Again you can see this watt value. Watt value we don't ask before we buy electrical appliance, we don't ask, but we must ask this also before we buy. Voltage, frequency and everything given, made where, from which country and everything we ask, but we don't ask this watt value mostly. That's why I told very very important specification. Otherwise you have to pay more for the electricity bill, right? Again you can see in a house, this electric iron consume more electricity. Therefore you have to iron all the clothes at once, because if when the watt value is higher, if the duration also higher, then because time also matters here, power into time. But the next one, how to convert this half an hour or 0.5 hours into seconds, 60 into 60, that means 3600. You have to multiply this by 3600 to convert hours into seconds. So if 60 into 60 means 3600. How to convert hours into seconds? Multiplied by 3600. So therefore we call it P equals VI. P equals VI, power equal, there's an equation called energy equal power into time. What is the equation used here? Energy equal power into time, PT. P for power, T for time. So the power here 1200, time 0.5 into 3600 in seconds. So time should be in seconds. So therefore this electric kettle, iron, refrigerators, AC, so consume more electricity than the other electrical appliances. Then let's move on. You can see here again some of the this common, like from brand or from the different, like slightly it can change. So if you take a lamp like filament bulb, filament bulb mostly from 60, 40, 60, 100. Filament lamp 40 watt to 100 watt. 100 watt mostly. But LED, the watt value is lower than that. Tube light, it's lower than that, than the filament bulb. Then AC you can see 2000 watt. Electric oven 2000. Electric heater, this also it can change when the air conditioner the size increase, the watt value can go up to even 3000, 4000 watt. Then again I have given, so the tube light is around 40 watt, electric bulb 60 watt, radio set, TV around 150 watt. You can have an idea. So refrigerator, actually it's more than that. This must be a small refrigerator. If it is a large refrigerator, it's more than that. Now you can see when boiling water, electric kettle, electric iron consume a lot of electricity in your house. Therefore you have to be careful when you are frequently, if you are using them in your house, the electricity bill goes up. But remember, don't memorize any of these values. Don't memorize any of these values. You should have a rough idea which electrical appliances consume more electricity. How to decide that? By looking at the watt value. By watt value, not only the watt value, the duration also matters. So this is the equation which relate power, current and voltage. So power is equal to, look at the screen everyone, P for power, I for current in amperes, V for voltage. So this equation very important. Don't worry, I have given this in the theory tube, but this triangle they have not given. This is a very easy method. If you want to find power, if power is unknown, you can multiply these two, I into V, V into I. That is the first equation. So second equation, if you want to find the current, then what? P divided by V, P over V, P divided by V here. And the third one, if you want, you can take a screenshot or you can copy down this. So there are three variables. If you don't know one of these, you can use the data of the other two. If you want to find the voltage, then you can take P divided by I, P over I. So what you can copy down like this. You can make this like this. This side you can put multiplications. So this one division. You divide this side also, you divide. So then what is here? Power equal V into I. If you take this side P over I, then what is left? That is equal to voltage. If you want to find voltage, then P divided by I. If you want to find current, then P over V. If you want to find P, V into I, like that. Okay, so that is what this the same triangle. So if you remember this, you can find any of this easily without memorizing the data. So if you only can use the same concept, can remember the grade 10 physics, the last chapter, 19th lesson, V equals IR. So V is equal to what? You can use this way, V equals IR, voltage equals some student they find it difficult to memorize the equation, then you can remember this, V equals I into R, I into R, I into R, I into R. So if you take if you want to find voltage, then what? I into R. If you want to find current, what? V over R. Current equal V over R, like that. Understood? You can easily remember this. So this V equals IR equation very important. So you can check here, I equals V divided by R. Next one. So this equation everyone should remember. At least the initial equation you have to remember. Power of electrical appliances depends on what? Current and voltage. Current and voltage. By looking at only voltage, you can't tell whether this. By looking at only current, you can't decide. But anyway, in your house, remember, any plug point 230. Any plug point the voltage 230. Any plug point voltage 230. Therefore, whether it's the power depends on what? Whether it's consume more electricity or not depends on the current and the time taken. Current. So the current matters here. Whether it's consume more electricity or less depends on the current. So remember the power measured in watt. what means joules per second. What is capital W? That is also equal to joules per second. That is called rate of utilizing electricity. Rate of utilizing electricity. Remember the grade 10 also you have done power. What is grade 10 power? Grade 10 power equal, yes, work done divided by time taken. Work done divided by time taken. Grade 10 power. And the other equation for the grade 10 power, what is the other equation? Please copy down all three in one place. Everyone in your short notebook, write power equal work done over time taken. That is grade 10. Then second equation, grade 10 power. Power equal energy divided by time. Power equal energy divided by time. I put E over T. T in seconds. Time in seconds. And the third equation, number 2, energy over time. Number 3, this one. Number 3 is this, power equal VI, that is electricity power. This is grade 11, this is grade 10, this also grade 10. So 2 equations you learn in grade 10, the other one in grade 11. Right? Power equal VI. Actually this power equal energy over time also we use in grade 11 electricity. Right? Grade 11 electricity. Right. Then let's move on to the next one. Right. I'll move to the next slide. Now, before we, okay, I'll explain. This is also very interesting one. It involves a lot of chemistry and physics both. Before I explain this slide, let's complete your theory to the first part. I mean the under power and energy of electrical appliances, the first part. Okay, so take your theory to it. I told now power of an electrical appliances depends on 2 factors. Or the rate of energy dissipation, how fast it consume energy, utilize energy, depends on what? Number 1, right, voltage within bracket V, and second one current, that is capital I, the symbol. Therefore power of electrical appliance depends on these 2 factors, therefore power equal voltage times current. Symbol equation, right, P equals VI. Right. Then, so this is in, if you want, you can put an arrow and write here, power it's in watt, capital W, and voltage in volts, current in amperes. So sometimes they can give kilovolt or sometimes they can give milliamperes. You have to convert this into amperes. That's very, very important. V voltage in volts and current in amperes. So this equation you can use directly the symbol equation in the exam. No need to write the word equation. And one more thing you can write, what is also equal to what? Joules per second. Actual, the fundamental unit joules per second, but SI unit is watt. So this is the SI unit. Even in grade 10 you have learned it. SI unit is watt, but fundamental unit joules per second. Then, so please put 3 stars for this. Very, very important. You can get calculation from this equation. If you get a calculation from this equation, you can get marks for the equation also in the oral paper. They allocate 1 mark sometimes for the equation if it is essay or structured essay. Question number 16th one now. 16th one, amount of energy consumed, electrical energy consumed. So this is the rate, how fast it utilizes energy. So imagine you get 500 watt, say not 500, I'll take say 60 watt lamp. 60 watt lamp is what? 60 joules per second. It consumes 60 joules in 1 second. So part of the 60 joules can be light, heat. So part of this will be light, the rest will be heat, because there's a loss of energy in the form of heat from any lamp. Even if you take televisions, your television, So the sound energy coming out, imagine television, say 100 watt, say 150 watt television. So sound, certain amount of energy. Then light, again. Then heat, because this get heated up. So there's three forms of energy loss here. But actually we don't need heat from the television, only light and sound. So therefore this heat, that is a wastage of energy. Therefore nothing is 100% efficient here. Even if you are using your laptops or mobile phones, whatever, it's getting heated up. So that is wastage of energy in the form of heat. When you are operating any electrical device, or the certain amount of energy is lost in the form of heat. So therefore the entire input energy will not get in the form of useful energy. So there will be energy loss in different forms. So the number 16, energy consumed depends on two. So that means I told you earlier, duration matters. Duration matters. Whether you are ironing clothes 1 hour or 2 hours, whether you are watching the television 1 hour or 2 hours or 3 hours, whether you are staying in front of the screen of mobile phone or laptop screen, how many hours or how many seconds, the duration matters and the power matters. So only from the power you can decide this. Power tells how fast energy is consumed per second. Power means per second. So if you multiply that by 10 seconds, so at the end of 10 seconds you can calculate the total energy consumption. So therefore there are two factors. Number one, now these days during every year during February, from February to about around April, until about April, electricity consumption increases in Sri Lanka daytime. Most of the houses electricity bill goes up during this period. Why? Because of dry climate. Because most of the places the fans on and AC on. So AC sale also goes up this time. So they advertise, because marketing they advertise the AC advertisements will be more air conditioners this time, because it's hot. During December they don't advertise much air conditioners. So therefore it's the climate also matters for their sale, right? Okay. So during December they can market what? The heaters, solar heaters and all, to get hot water. But you don't need hot water during daytime, because daytime in Sri Lanka is hot anyway. So you don't need hot water daytime, but solar heaters produce it hot water daytime. So I mean solar heaters I'm talking about, solar therm. Right. Then energy, electrical energy consumed by electrical appliances depends on two factors. Number one, first one, right? Power of the electrical appliance. Power of the electrical appliance. That's what you should ask before you buy any electrical appliance from the electrical shop. Power of electrical appliance. You can write it within bracket P, power. Second one, duration, time. Operating time matters. Operating time. Or you can just write time. Time of operating time. So that is called energy equal power into time. Energy equal power into time. Energy equal power into time. So energy, you can write the equation E equals PT. E equals PT. T simple T. T simple T. Please put 3 stars for this also, very very important. You are getting calculation from this equation. They will not give this expression or the equation in the exam. Here also you can write power should be in what? Be careful, sometimes they can give in kilowatt. If they give in kilowatt, you have to convert into what? Very very important, watt. And time should be in seconds. Time should be in seconds. Mostly they give in minutes or hours. You have to convert minutes or hours into seconds. Otherwise no marks in the exam. Be careful about units. Be careful about units. Right. Extremely important. So remember, now grade 10 you had done V equals IR. You will not get equations only from V equals IR. Equivalent resistance, parallel connection, series connection, all this. Equivalent resistance you calculate. Voltage V equals IR. But here, if you only can calculate voltage from this also, not only from Ohm's law, you can how to calculate the voltage. Voltage equal power over time. Sorry, power divided by current. You can rearrange this equation. You can rearrange this equation. Voltage equal power over current. Right? If they give any two of this, you can find the third one. That's what it means. Anyone still copying down? Shall I move down? Okay. Shall I erase this? Anyone still copying down? Right, done. Then next part. There's one more thing. Look at the screen. This is also very, very important. I told you now power equal energy equal power into time. Energy equal power into time. Now there's one more equation for power energy equal. Now here I told energy equal power into time. Now we can substitute this power into time. Earlier, can you remember we wrote power P equals VI? Previous one under number 16, 15, you wrote P equals VI. So we can replace this P with VI. That means instead of power we can write voltage times current times into time. Again what? Power can be replaced with voltage and current. VI. VI. So therefore, if I replace this power with VI, then I can write energy equals VIT. So what are the two equations to calculate the energy consumption of an electrical appliance? What are the two equations? Energy equal power into time. That is the first one. Second one, write energy equal, number one, write energy equal power into time. Number two, write energy equal VIT. What is V? Voltage. Voltage. What is I? Current. But it should be in amperes, not kiloamperes, not milliamperes. Voltage volts, for current amperes, time in seconds. Okay, so I gave now three equations. What are the three equations? Number one, power equal VI. Number two, energy equals power into time. Third equation, energy equal VIT. Okay, so these are the three equations you have to remember for the exam. Depending on the data given, you have to choose the equation. Okay, so what is the energy you get? Answer you get in joules. So what is the energy here? That you get the final answer in joules, capital J. Right. Okay. So we'll be doing calculation at the end of this tute. I have given a lot of questions, the past paper questions. At the end of this theory tute, I'll be discussing them Saturday night paper class. Saturday night paper class. Now I'll move back to the PowerPoint slide. PowerPoint slides. Okay. Now let's see what are the methods available to boil water. Any house these days, boiling of water, I mean actually because of COVID, you drink hot water, you steam, and frequently you boil water now. Most of the people are at home, and the consumption of food also has increased because most of the time you're at home and then nothing to do, you are eating and sleeping. So most of the people are at home. So now eating of sweets now increase, and you can, with the blood sugar level can go up these days because less physical activity. No one is going to work, all I staying at home. Therefore those things also important, right? Now you can see here one method. This is the traditional method of boiling water. Even in rural, even now in Sri Lanka rural areas they use this method. What is firewood hearth, daralipa. So traditional method of boiling water. So there's a metal kettle here. Actually what happens here, when you boil water, before water the pot should be heated up. This kettle should be heated up. The metal should get heated up by conduction before water. There will be an energy loss. Large quantity of energy, heat is lost to the environment. Heat lost to the environment. And the other problem by radiation. So they can ask questions by combining electricity and everything. And a lot of gases, I mean harmful gases, carbon monoxide, carbon dioxide, unburned carbon particles. Why this kettle turns black? Because of the deposition of carbon, deposition of unburned carbon particles. Due to the deposition of unburned carbon particles, that's why it's turned black, outer surface. But anyway, black surface absorb heat more efficiently than the white or the shiny surfaces. Now let's see what are the, okay, who can tell me what are the other methods that can be used to boil water other than this one? But in urban areas we don't use this method. This method is mostly in rural areas, abundance of firewood. Yes, what are the other methods of boiling water? Dasulu?
By the gas cooker. Sorry,
Gas cooker. Sandali, what are the other methods of boiling water? Gas cooker, okay.
By using the heater.
Okay, heater, gas cooker, heater. Other than that, firewood, gas cooker, heater. What are the other methods of boiling water in your house that can be used to boil water? The methods, Dasula, Shavindi.
By using hot plate.
Electric kettle.
Electric kettle. Dasula, what do you? I couldn't follow. Dasula.
Hot plate.
Hot plate, electric kettle, okay, gas cooker, right. Now let's see, let's compare. Okay, Akhilesh, yes, any other method?
Solar energy.
Yes, solar heaters, very good. Solar heaters, gas cooker, electric kettle, electric hot plate, and then this one, firewood hearth. There are about 5-6 methods. Now in the exam they can give, yes, 5. Any other method? Can't hear.
Immersing.
Immersion, yeah, very good, yes. Immersion heater, very good. Immersion heater. Okay, now this is again what? This one is less air pollution than the previous one. So in most of the urban areas we use this method. But again the problem is here we use LP gas, LPG. That means propane and butane. Propane and butane gases. What are the two gases in the gas cylinder? Propane and butane. Propane C3H8, butane C4H10. These are the two gases present in the LP gas cylinder, propane and butane. Hydrocarbons, these two are also called hydrocarbons. Hydrocarbons. Now the problem again, what happened? Wastage of heat energy, I mean large quantity of heat is utilized for heat in the container. Container should get heated up before water. And when the container gets heated up, heat is lost to the environment from the container. Heat lost to the environment from the container. Plus, there's a wastage of directly from the flame also heat loss. Heat loss directly from the flame, heat loss from the pot, and heat loss from this end also. Therefore, it's a low efficiency, this method. But it's better than the, I mean, you have to consider the availability of the energy source also. So therefore you should know how to contrast and comment on these methods. So air pollution less this method because you don't get a lot of smoke like in the firewood hearth, LP gas. Hydrocarbon only carbon dioxide, but little bit of carbon monoxide also can be emitted if it is not complete combustion. Remember, they will give different 3-4 methods like this. They can ask questions, okay, to compare one advantages of that method than this. So this is the immersion heater. Now immersion heater, what happened? No gases coming out, no gases, no gaseous pollutants, no gaseous emission, no gas emission. Plus, you immerse this inside the pot. I mean, whatever the container, you have water here. So heat is directly transferred to water. Heat is directly transferred to water. Heat is directly transferred to water. It is directly transferred to water. But the problem is when there's a power cut, you can't boil water. Power cut, gas cooker can, firewood hearth can. So therefore, but the other problem is this. This immersion heater, sometimes in the exam, if you only can make a small this diagram and ask, once in the old papers they ask a question. Immersion heater, this part is made of nichrome. It is an alloy called nickel and chromium. This part is nichrome. Nichrome has high resistance, high melting point, not subjected to rusting. So they can ask why nichrome is used. What are the constituents? Nickel plus chromium. Nichrome is an alloy, high melting point, high resistance, and conductor of heat and electricity. Why it is coiled? Can't they put a directly rod here? Can't they put a direct rod here? Why it is coiled? Why it's coiled one? Can't they put a direct rod like this? Remember grade 10 you have learned, when the length increases, resistance increases. When the length increases, resistance increases. When the resistance increases, heating effect is more. More heat is generated. Long wires, high resistance gets overheated. Right? If you have between the plug point and the your electric kettle or whatever, if there are 1 kilometer length wire, so it's so many times, then what happen? Coil can get overheated, wire can get overheated, so it can call electrical fire. Therefore here it's good, we need heat, but here is copper, Cu, inside this cable copper, here nichrome. But the problem is what? If you forget, now this is the most dangerous thing. Imagine you keep on boiling water. It is not get off, it will not off automatically. So you boil water, water evaporate, and the water level goes down. Water level goes down. What happened? You are watching the television. Mother is watching teledrama, or your sister is watching a teledrama, and it is immersed and it switches on. So water level goes down, then it's a plastic con. Plastic one, what happened? Plastic will melt now, and you get a trip goes off. Now there's a leakage. Trip goes off. When the trip goes off, or the mother or your sister will remember, heater is on, right? Or else they get the smoke coming out from when burning the they get like when the plastic get burned, like when get heated up, what happened? They get the smell, right? Then only they remember. Or else, so that is the risk here. That is the risk. So you have to be always with this. I mean, you have to remember to off this when it begins to boil. Same scenario the gas cooker. So if you keep on if you don't off, now there's a sound you get. Some pot you get a sound when it's going to boil, you get a sound here. So that gives signal that it's you have to off the gas cooker. Otherwise here also wastage of gas. So when it begins to boil, you have to off. Otherwise you keep on boiling this, and water getting evaporated, and your gas consumption increase. That is wastage of energy and money. And the other most, so this is like very important, like day-to-day life. Again this one. Now this is dangerous. Why it is dangerous? Both this not good to our health. Who can tell me why it is not good to our health? Not good to our health. This method of you boiling water in this kind of container, not good to our health. Why? Don't ever let anyone to boil water in this way. Why? Yes?
Because plastic can get dissolved in water.
Yes,
Plastic
correct.
can dissolve and
Plastic,
add
very
to
good. Yes,
water.
plastic, dangerous. When water get heated up, sometimes microwave heatable plastic available, right? Some plastic not thermally stable. Therefore, some plastic contaminants, the water can get contaminants or chemicals can be released from the plastic into water. Don't ever store hot water for making plenty tea, drinking purposes. Don't ever boil water in a plastic container. Not only to boil, don't ever store hot water in a plastic cup. If you want to get a cancer, you can practice that. Plastic, I mean food grade or high quality plastic, okay. Plastic containers, you should not store hot liquids. Not good. It can be cancerous. Even microwave, you don't put the plastic containers. Now what is this? The next method of boiling water, hot plate. What is called hot plate? Hot plate. So you can put the container here, and direct heat is directly transferred from the hot plate to the container, and container to the whatever inside. Right? So that is the other method. This method also it's much better than the previous one. Then this is electric kettle. Electric kettle, with compared to the immersion heater, this is much safer because it's automatically off. When the water begins to boil, it's automatically go off. And again, if be careful whether this is the outer cover in plastic. Plastic not good here. Plastic not good. So when you buy, you have to be. It's better to have stainless steel. Then next one. So this is the other method, eco-friendly method. Can you remember the solar heaters? All the parallel rays of light, all the rays parallel to the principal axis. After reaching here, it's get reflected to the. So it's get converged to the convergent point like this. So here the heat is produced, and this is silver mirror. Silver colored surface is a good reflector of IR or thermal radiation. So then you have to keep this outer surface black. It's better to have black surface bottom, and here water you can heat, or you can, so it's a solar heater. So you have done in optic lesson. So this is environmental friendly method, but you can't boil, it takes time, and it's not possible in all the areas because of the climatic condition. But at least if you can heat this up to 50 Celsius, and then you can transfer this into the gas cooker or whatever, then you can heat only from 50 to 100. Then you can save electricity, or you can save gas, rather than directly you put the tap water here. Tap water at 25 Celsius, say 20 Celsius to 100, the gap is 80 degrees. Can you remember Q equals MC theta? If you keep the theta low, Q also decrease. If you keep the theta low, Q also the amount of heat required less. If the amount of heat required less, time taken less, and the gas consumption also less. Therefore, instead of directly transferring tap water into the pot, you can get from solar heater, transfer water into the rice or rice cooker or whatever partially heated water you can use. Then you can minimize, you can save energy in the house. Right, next one. This is the most advanced method. Who can tell me what is this? What is this? Who can tell me what is this? Anyone? Anyone? Any volunteers? This is the most efficient method of heating stuff. Yes, Lonita? Arosha? Ice?
Induction cooker.
Yeah, very good, excellent. Induction cooker. So, induction cooker. Okay, who can tell me the benefits of induction cooker? One benefit of induction cooker than gas cooker and over gas cooker and hot plate over gas cooker. So what are the advantages? I mean, with compared to the gas cooker, tell me. Okay, gas cooker versus induction cooker. What are the advantages? Any advantages, Arosh?
Can control the temperature.
Can control the temperature. Okay, we can control the heat transferred. Yeah, okay, we without roasting or without overheating. Yes. Okay. Any other benefit of this? Benefits or the advantages of this than the gas cooker? It's given in your textbook. It's given in your textbook. Now in the
No emission of gases.
yeah, no air pollution. No air pollution. Can control heat or can control temperature. We can get the required temperature. Gas cooker, you don't know the temperature exactly. Can set the temperature. What else? Any other benefits of this induction cooker? Remember, I don't know how many of you have used this. This no heat generated here, no heat on the this glass. I mean the what is it called, hot top. This one, no heat loss. So if you only can touch this container, it won't get heated up. Only food gets heated up. Only food is heated up, not the induction cooker, the surface, not the pot. Only food is heated up. Only food is heated up. Remember, this is linked with your electromagnetism lesson, grade 11, chapter 13. You learn electromagnetism lesson. So this is induction cooker. If you only can search in the internet how it works, electromagnetic, I mean, we call it electromagnetic field is used. Electromagnetic field is used to generate heat in food. So, okay, so this is very, very important. That is the most advanced method. No air pollution, no gas emission, and it's take less time, plus no need of fuel. Imagine there's a shortage of gas, no gas cylinders in the market, then you can't cook the curry. Rice cooker, you can boil rice but not the curry. So if when gas is not available, if you have a gas cooker, if the gas cooker, if you can't use, there's no gas, there's a shortage of gas, LP gas, so it's run out in your house, the gas cylinder is over now, no gas inside the gas cylinder. So until you refill the gas cylinder, you can't cook any curry. So then the best solution is what? You can use the rice cooker to boil rice, and you can use induction cooker to make the curry. So therefore, this is very energy efficiency is very high. Energy efficiency is high induction cooker than any other cooker. Right? Gas cooker, lot of wastage of, I mean, more energy is lost, more heat is lost. But here, heat loss is minimum. Induction cooker. But it bit expensive. You can't use any. What are the disadvantages? You can't use clay pot here. You can't use that like aluminium pot. There's a separate container. You have to use the separate container. You have to buy separately. Induction cooker bit expensive, about 5,000 to 10,000 normal average range, right? About 5,000 rupees or above, normal one, and then separate content you have to take. But it takes less time, no air pollution, no smoke coming out. When there's when no gas in the gas cylinder, you can use induction cooker to make the curry, right? Very important. And you can set the temperature, and it takes less time, maybe few seconds sometimes, to boil the curry, right? It's given in a textbook also. Then, so this is how it works. Electricity is required, but when there's a power cut, you can't use this. So this one we'll be discussing under electromagnetism lesson. Don't worry about that, right? Okay. So the most important advantage bringing home an induction cooker is safety. So safety means what? Gas cooker, safety is very important. I forgot to tell that. Safety is very, very important. You can touch this surface, no problem. It's not hot, not hot. Pot also not hot. Pot you can touch. Plate you can. So therefore, whatever in the if there's a small one in the house, and then if they touch the the gas cooker, it's they will get burned definitely. So you will not get burned from this. You will not get burned from this. You can get electrocuted somewhere if there's a leakage, but you will not get burned even if you touch this surface. Surface won't get heated up. Very, very important. So what is used here? Magnetism to generate heat. So that's why we call it electromagnetic field is used to generate heat here. So no risk of getting burned. No risk of getting burned from the naked flame. No naked flame here. And only the area inside the ring gets heated up. Area inside the ring gets heated up, and not surrounding areas. Right. Then so no danger, there's no danger of getting burned accidentally by touching any other part of the induction cooker. So time taken to cool down is extremely less. That was there. So extremely safe to use for the children also. Right. Next one. Okay, now let's see in the laboratory. Okay, that is in the kitchen. That is in the kitchen. In the laboratory, in science laboratory, what are the methods of heating the stuff? Okay. The devices, compounds we can use to heat chemical or whatever, for heating or decomposing substances, for heating solution. So we use Bunsen burner. This is Bunsen burner, and this is spirit lamp. Spirit lamp. Bunsen burner, and this is spirit lamp. Okay, so Bunsen burner, less air pollution than the spirit lamp. So this is yellow flame, that is incomplete combustion. Yellow flame, more gaseous emission, more harmful, like carbon monoxide, carbon dioxide emission more. So this one less carbon monoxide emission is less, and it is complete combustion. So this one can get more heat, it takes less time. So this one takes more time. So this is in the chemistry lab, and again this is called again heater, like we call it sometimes. This is also used in the laboratory to heat solutions. This is called what is called hot plate. Hot plate. Can you remember steam distillation? Steam distillation we use heat in mantle. Hot plate you can use. So here also no gas emission, no air pollution. And heat is there can be heat loss to the surrounding, but air pollution, no air pollution. But when you produce electricity using coal, there will be air pollution in the country. Again, this is called water bath. Can you remember the water bath? This is available in laboratories. So you can use the test tubes here. Imagine Benedict test. You have to heat the solution until you get the brick red color, right? So you can immerse test tube here. A lot of test tubes you can heat at once, right? This is using this the stainless steel covering, and inside you can have a heater to boil water, to heat water to the required temperature. You can control the temperature also. This is used, we call it water bath. Water bath. Right. Next one. This is what we use. We call it heat in mantle. Heat in mantle. This is the heat loss is less than. So there's a heat in like this coil here inside. When the coil is heated up, the heat is transferred to water. Heat is transferred to the water inside. That's how it happens. Right. Then next one, lamps. So that's what we are going to discuss next, about lighting. So various electrical components and various methods of heating, cooking, so appliances I discussed now. They have given this in your textbook also at the front page. I'll move back to the textbook also, the cover. Okay, let me show you. Authors have asked questions like this, that's why. Right. Let me explain before electronics. Okay, you can see the front page of your textbook, first page of your textbook. Right. So they have given here, can you see here what is this? This is an induction cooker and microwave oven. So they are more efficient than gas cooker. Microwave oven and induction cooker is more efficient than even microwave. So this is the electric heater that is used in the laboratories also for heating the solution. So you should know how to compare these things. You should know how to compare advantages, disadvantages, power consumption, all this you should know, right? Okay. So they have given main forms of energy conversion in some electrical appliances. Mostly heat, then some of this light, light and sound, both television, right? Okay, back to this PowerPoint slide again. Okay. Now let's see how to compare the lamps. There are three types of lamps we are using. So earlier we use filament bulbs. The filament is made of tungsten. What is the symbol of tungsten? Capital W. Tungsten, the symbol is capital W. It has high melting point. High melting point. And it has high resistance. Why tungsten is used? There are so many other metals. Why tungsten is used? High melting point and high resistance. And it gets heated up. It becomes red hot. When current passes, immediately this becomes red hot. And inside argon or noble gas, if they keep a vacuum, you will not get light. So there must be a gas inside. Sometimes xenon gas filled in minus cap lamps, ships and all, they use different lamps, krypton, xenon, but mostly they use argon, nitrogen, helium, noble gases used. If they fill normal air inside, what happen? Filament get burned. If you fill oxygen, normal air contain, atmospheric air contain oxygen. Oxygen react with the filament at high temperature and filament get burned, which must be airtight. So there must be, if air enters into this, definitely the filament get burned, tungsten filament. Right? So that is very, very important. Plus, the other most important thing, this inert gas. Inert gas important, tungsten filament, because you might not believe sometimes. You don't learn how electric bulb works. You will not learn this in your syllabus separately, the design of the bulbs and each part, the main role and how it works. But 1990s, once in the older paper, they gave an electric bulb and asked questions like this. Why filament? What features used to make the filament? Why is tungsten is more suitable than the other metals for making the filament? Give three. Why it is coiled here, right? And why here lead wire? Why this part is not tungsten? Right? Why argon is used? What is the gas filled inside? A more suitable gas. And why it is not filled with atmospheric air? So they can ask questions like that. Right? Okay. So but the main problem is tungsten one, you get nearly 60% heat than light. We don't need heat from the lamp, we need only light. But here 40% will be light, 60 to 70% heat. From a normal filament bulb, we need light, but it emits heat nearly 60. So around 40% you get light. That means very low efficiency. Very low efficiency. So if you get 100-watt lamp, that means electrical energy 100 joules per second. From 100 joules, 40 joules become light, 60 joules become heat. So that means your interior, inside your house get inside your room gets heated up due to this. The next part. What is the next type of bulb mostly used after filament bulb? Tube light, or we call it fluorescent lamp. Fluorescent lamp or tube light. Fluorescent tubes. So there are no filament used. Fluorescent material is used. When UV light falls on the fluorescent material, bright light is emitted. So this is better than the filament bulb. That is better than the filament bulb. Next one, CFL. The main problem with CFL contain mercury. CFL contain mercury. So what is the problem with mercury? Mercury highly toxic. They have given, I think, toxic symbol also is not clear here. This contain mercury. So here can you see, I think it's mercury. Here mercury. Can you see this this part? The mercury is there, Hg. So after about 1 or 2 years, after about, you can use about 8,000 hours, not 8 hours, and the max lifetime about 8,000 hours. 8,000 hours. So after about 8,000 hours, after about 1 or 2 years, you have to replace the CFL lamp. CFL means compact fluorescent lamp. Compact fluorescent. Again, inside there's a white colored powder or coating fluorescent material. So UV light is why mercury is used to generate UV. When UV light falls on the fluorescent material, bright light is emitted. So the problem with mercury. So mercury is highly toxic. Then mercury is released to the environment, and that mercury can return to your body through food and water. So mercury is toxic heavy metal, highly toxic. One of the most toxic metal is mercury. So what is the main disadvantage of CFL? It's better than filament bulb and tube light. Filament bulb, but the problem is not environmental friendly. So therefore, now after first we started with that filament bulb, then tube light, then CFL. Now we use the fourth type. What is that? LED. So LED, the main benefit, no mercury, environmental friendly, no mercury, no toxic heavy metal, and long lifetime, about 50,000 hours. Long lifetime is about 50,000 hours you can use. Even if you take multimedia projector, LED multimedia projector, you can use more than 50,000 hours. The lamp you can use more than 50,000 hours. Long lifetime. Eco-friendly. Why no mercury? Eco-friendly. Plus the other one, more light, less heat, more light than the any other lamp. Less heat, more light. That means high efficiency. In the exam, if they ask what are the advantages of LEDs than the other lamps, what to write? Long lifetime, high efficiency, environmental friendly. Other lamps not available in different colors. LED available in different colors. Traffic light. What is called the signal? I mean, what is this called? You get 3 colors. Green, yellow, and red. No, yeah. So available in different colors available. Otherwise, you have to put a laminating sheet for the LED or CFL and filament. You have to put a laminating sheet, right? But here, no need to put a lamination. You can have LEDs available in different colors. So that means it's very important in case of traffic light, and it's a low power consumption, high efficiency, low power consumption. If you take 20 watt LED equal 100 watt or more than that filament bulb 100 watt, you can get the same light from 20 watt LED. So what are the advantages? Long lifetime, high efficiency, low power consumption, environmental friendly or eco-friendly, available in different colors, plus high intensity of light. Now LED everywhere. LED car headlight. LEDs are used as car headlight. Some vehicles, this hybrid vehicles, the headlamp LED. Then parking lights, LED, or signal lights of vehicles. Most of the lamps now LED because low power consumption. Signal light, LED light, parking light, all these LED lamps. Then multimedia projector lamps. Multimedia, these are the applications of LED. Multimedia projector lamps, LED projectors. Televisions, we use LED televisions. Then traffic lights we use LED. So it's widely used now. And light in houses, house bulbs or lamps, LED. Light in houses we use LED. Therefore LED becoming very popular now because of these benefits. Now most of the CFL and CFL like kind of gradually it's decreasing the usage, and the filament bulb also. LED you will learn how it is produced in under next lesson, electronic lesson. We are discussing what is LED stand for, what light emitting diode. This diode, how diode is produced, how it works, we'll be discussing under chapter 11 electronics next lesson. And the other, remember the other benefit, LED, high intensity of light. Can you see the name boards? Name boards, LED name boards, advertising, they use LED because high intensity of light. Even in your computer, laptops, mobile phones, can you see there's an indicator lamp? When the AC is on, green light glows. When the AC is not working, red light. Or your charger or the mobile phone, television, the indicator lamps, when you on the television, green light on. When you off the television, red light is on. So all these are LEDs, low power consumption. Sometimes some of the switches and the plug point, there's a small indicator lamp. So they are used as indicator lamps. Your laptop charger or mobile charger, there's an indicator lamp. When the charge is on, it goes green or red or whatever you get. It indicates whether the charge is working properly or not. Indicator lamps. So therefore LED light emitting diodes, very important. What are the main raw materials used to make LED? Silicon, germanium, arsenic. So these are the main raw materials used to make LED. Semiconductors are used. So I'll explain about that in detail under electronic lesson, right? So what are the now they can do different types of lamps. Now I told what, filament bulb, then I told fluorescent lamps or the tube light, then I told CFL, compact. Don't mix up, this is CFC, right? CFC, HFC, all these had different meaning. CFC, chlorofluorocarbon, then CFL, compact fluorescent lamp. So be careful what these two. CFC, chlorofluorocarbon, that is a gas, that's a refrigerant, that's also linked with air conditioners and all. Okay. CFL, compact fluorescent lamps, and then LED. Next one. Now this is what I have given. I have given in your theory tube. Look at the screen now. Theory tube. How to compare the advantages and disadvantages of how to compare the lamps. Okay, look at the screen. So this is given in your textbook also. Now when you compare these four types of lamps, various types of bulbs, advantages of LED other than the other types of lamp. LED you can see 50,000 hours, long lifetime. You can put an arrow, even you can write long lifetime. Long lifetime. That means what? When you use CFL, 8,000 into how many, like 8 into 4, right? Okay, that means when you use one LED, you have to use how many CFL? 4 CFL. 8 times for 48, right? 48,000. That means 4 LEDs, when one LED is used, 4 LEDs mercury released to the environment. CFL, 4 CFL released to the environment. Therefore you can reduce the releasing of this harmful chemicals or the mercury to the environment if you switch from CFL to LED. Filament bulb, the main problem you can see what, lifetime also very short, and the power is very high. That means power consumption means electricity bill goes up. So here the lowest watt value, low watt value, LED, low watt value means low power consumption, long lifetime. Okay, write the advantages. Number 1, low power consumption. Please write number 1 LED, highlight the word advantages of LED, everyone. Advantages of LED, right? Low power consumption. Low power consumption. Number 2, right? Long lifetime. Long lifetime. So look at here, 50,000 hours. Long lifetime. But it depends on the brand, like, because sometimes there are low quality LEDs also they are in the market. Long lifetime. So they give about nearly 2 years warranty. But I don't think filament bulb they will ever give warranty here. Right? LED CFL they give about 1 year or maybe 1 year, but LED they give 2-3 years warranty. Long lifetime plus or high durability. Number 3, right? Eco-friendly or environmental friendly. Within bracket, right? No mercury. Eco-friendly means environmental friendly because no mercury, no Hg. Can you all please write, put an arrow towards CFL, right? Mercury present. Please put an arrow towards CFL, right? Mercury present. LED, right? Mercury absent. No mercury in LED. That's why it's LED more eco-friendly. Hg mercury. Right? Number 4, fourth advantage. Yes. High efficiency. High efficiency means what? Less heat, more light. High efficiency. Please write if you want in front of this in front of high efficiency, right? High efficiency. Within bracket, right? More light, less heat. More light using, I mean, that is just to understand, otherwise you must be wondering what is high efficiency. More light because efficiency depends on light. I mean, we need light, not heat. From a lamp we are not expecting, like, we are not going to iron clothes from the lamp, right? We need only light, not heat. But okay, who can give, I'll ask a very interesting question now. Let's see how many of you can give the answer for this. More light. Tell me an instance where you get only light, no heat at all. Light without heat. An instance, natural phenomena. Natural phenomena where only light is coming out without heat. What is this phenomena called? Light without heat called what? Netuli, yes?
Sir, is it the lightning?
Lightning, you get heat. You get heat also. Yeah, that also light is produced naturally. Okay, lightning also natural phenomena where light is produced, heat also can come. Any other instance other than that light is produced in I mean without light, without heat, because gas cooker both light and heat, bulb both light and heat, right? If you take a fire, both light and heat, right? Any fire, both light and heat. I am asking light without heat, an instance, natural instance, not man-made one. Hemru?
Firefly.
Very good, excellent answer. Firefly, very good. Firefly, kala mediriya. Fire. There are some other animals also. Firefly, light without heat. No combustion there. Using enzymatic reaction, biochemical reaction. What is the single term used for this? Who can tell me that answer for that? What is, I mean, asking additional information. This is very interesting in at university level. You will learn this in the future if you enter university one day chemistry. Yes, Shavindi, what is this called?
Luminescence.
Very good, luminescence. Luminescence. What is luminescence? Emission of light without heat. Again, I am telling what is luminescence? Emission of light without heat. If you want to write that in your short notebook, it's they not ask this for the exam, right? This additional information, right? Because it's interesting. They should have put this in the lesson. I mean, in your syllabus. So it's very interesting part. Luminescence. Luminescence. There are two types: chemiluminescence and bioluminescence. What is that? Chemiluminescence and bioluminescence. Chemiluminescence and so firefly, bioluminescence. Natural organism, living organisms. There's an enzyme called luciferase in firefly. Okay, luciferase. Now the other instance, chemiluminescence. Using chemical reactions also you can emit light without heat. That is called chemiluminescence. Right. Okay. So that is additional information. So what are the advantages of LED over the others? Long lifetime, low power consumption, eco-friendly, high efficiency, and write one more advantage, number 5. Available in different variety of colors. Available in different colors. Example, right? Color light. Example, right? Color light. More light, less heat. No, more light, less heat. Firefly, no heat. Right? Number 5. Available in different colors. available in different colors, and high intensity of light also you can write different colors. You can search in the internet. There are some lamps are like, you know, yellow warm light, daylight, cool bright daylight, cool daylight. Some when you buy lamps, so you don't check this. You just pay money and get the lamp. Check which color is more you know, I mean, good to your eyes. So which which light makes you sleepy, right? For reading, which light is better, cool daylight or warm light, like yellow, like color light, you get light. So like that, you there's a luminescence and temperature. So all this very important. Blue violet light not good to your screen. Now everyone is looking at the screen. All your screen emit blue violet light. So if possible, you can use a blue violet light filter or glasses to filter, because blue violet light can harm your retina, can damage your retina. So that's why these days, don't, since most of you all are joining looking at the screen for the online classes, so reduce the time spent in front of the screen the other time, right? On all the other times, reduce the time that you are in front of the screen, because otherwise you will get eye problem when COVID is over, before COVID is over, right? Or you get headache and different issues, health issues with this. Therefore it's not good to look at short distance. Best thing, if you have a HDMI cable, you can connect your laptop to a television, TV. Through HDMI cable you can connect to a, then you can stay at least 6-7 feet away from the screen, no? So television about 6-7 feet away, but if you are looking at the computer, laptop, maybe 1 or 2 feet, 6 feet away from the television. Laptop maybe 1 feet or less than that, and mobile phone, it's about maybe like 6 inches or less than that, or not even 6 inches, so 3 inch or few centimeters mobile phone. So therefore when the gap is less, so it's not good to your health, right? It's not good to your health. So therefore these things also you have to be careful during online classes, right? And continuously don't look at the screen. So from time to time you should better look at long distance, but at night you can't do this. Daytime, if you are joining online classes, you can after every 6-15 minutes you can look at long distance greenery, the outside. If you are staying near a window, you don't look at short distance continuously. It's not good to your health, right? Okay, anyway, then next one, I'll erase the screen. Did you all finish copying down now? And if you only can add one more, high intensity of light. If possible, please write the instances of using right at the bottom, if possible, write instances of using what, LEDs, applications, or the instances of using LEDs. If possible, if you have space, write applications or the instances of using LEDs. I gave few instances of using LEDs, right? Number 1, light in houses. For light in houses, instances of using LEDs. Instances of using LEDs, right? Light in houses. Then you can write traffic lights. Traffic lights, a lot of LEDs they use in 3 different colors, not only one lamp. Then vehicle lights, vehicle lamps. Televisions. Then projector lamps, projectors, they use LEDs. Then vehicles. Then indicator lamps of electrical appliances. Indicator lamps of electrical appliances. I told you, your laptop charger, mobile phone charger, then television or the air conditioner. The indicator lamps, when you off one color, when it's on green, when it's off red, like that. Indicator lamps of electrical appliances. Even if you take, you might not believe this, if you have a remote controller in your house, remote control, television remote or whatever remote, there's a LED front end. Your remote, after the class you can check, there's a small lamp here in your remote. This emit what? Infrared. You had done it in I think under electromagnetic spectrum also. It's using remote controllers of televisions and VCD, multi DVD players. So they use LED, but that LED doesn't emit light, it emit infrared, IR. Okay, so some LEDs emit IR, some LEDs can emit UV also. So this is visible light. Multimedia projector then LED televisions, LED vehicle lamp lights, indicator lamps, traffic lights, light in houses. There are many more. Right. India then for I mean advertising signs, even name board of bus and all, the long distance bus, they put the name board also, LEDs, advertising. Right. Then next part, methods of increasing the efficiency and reducing the wastage of energy of electrical appliances. So right, number one, how to increase the efficiency and reduce the wastage of energy when using electrical appliances. Number one, right, use of microwave or induction cooker. Use of, I put microwave or induction cooker for cooking food or heating food. Induction cooker for heating food. Even for cooking you can use heating food. Why efficiently? No air pollution plus no heat loss to the environment like in the gas cooker. Directly food is heated. Microwave, directly food is heated, not the plate, not the container. Induction cooker, the food is heated, not the container. So no heat loss than the gas cooker, traditional gas cooker or the firewood hearth. Yeah, what are the other instances? You can use hot plate or immersion heater for boiling water. Use of immersion heater or electric kettle for boiling water instead of gas cooker for boiling water. If I give this question to grade 6 7 student, they write, don't keep the door of the refrigerator open long hours. Switch off the unnecessarily, I mean the lamps without keeping the lamps on unnecessarily. Switch off the fan after using, like that. So those are like common ones. So but other than that, you have to learn, put something new like this. Using appliances with low watt value. Using components of low watt value, low wattage, watt value, low power consumption. Using appliances with low watt value. Power with low watt value. Then energy consumption is less. So either 20 watt LED or 100 watt filament bulb. Selecting or using appliances with low watt value. Same appliance, same purpose, but one has low watt value, then you should go for that one rather than the other one. Understood? Then in national you can write using LEDs for lighting houses. Using LEDs for lighting houses. Using LEDs for lighting houses. I'll give one more example. There are 3 types of fans you are using. Which fan? Okay, I'll put stand fan. Okay, I'll put like this: table fan, number 1. Number 2, stand fan. Number 3, ceiling fan. Which one has the lowest power consumption? Who can tell me? Ceiling fan, not only for science actually, for your day-to-day life, like because everyone is using electricity, everyone is getting an electricity bill. So table fans, this should be stand fan, and the other one is ceiling fan. Which one has the lowest power consumption out of these 3? Yes, who can tell me the answer? Randima, Vishal, Tirani?
Table fan.
Table fan.
Yes, table fan around 35 watt, even less than that. So this is around 60 watt. So around 35 watt roughly. This one will be around 150 watt. You can see here it's almost double, or 3 times. So therefore you have to be careful about that also. When you buy something, if you are only in the room, so then you better use a table fan rather than using ceiling fan. So 3 times, so about 5 times. Table fan to ceiling fan, the power consumption or the energy consumption 5 times. So you can write that also. Use of table fan instead of ceiling fan, then ceiling fan. So add one more 5, number 5 higher, use of table fan instead of ceiling fans. If you can cool your house without using fans, that's better. Architecture, like natural ventilation, you can set the doors and the windows towards the direction of wind, and on the other end you can have again some opening, then naturally wind, the natural air circulation. Use of table fan instead of ceiling fan. Right. So these are the some other methods. So other than writing those, because anyway you can write ironing clothes at once, so that also okay. But I expect more than that here, right? Ironing clothes at once, and not keeping the door of the refrigerator open long hours. And you should not put hot stuff inside the refrigerator immediately after cooking. Don't let anyone to put the cooked food inside the refrigerator, because you have to let it cool outside at least to the normal temperature, at least to about 30-40 Celsius. Immediately after cooking, if you are putting the food into the refrigerator, then the energy consumption inside the refrigerator goes up. And if you keep the refrigerator, the door open, the energy consumption goes up. If you are putting the hot stuff not inside the refrigerator, above the refrigerator, sometimes we are used to put various stuff, objects, then energy consumption goes up. When the refrigerator and the wall, there must be a gap for the better circulation of heated air. If you keep that gap also very low, then also the energy consumption goes up. Right? So those things very important. And the other thing is what, immediately after taking the food in the refrigerator without letting it cool to the normal temperature, if you are again directly using any other method, whatever gas cooker, whatever method, then also the more energy is consumed, because low temperature to high temperature, theta increase, theta temperature difference increase. You can write one more if you want. Ironing all the ironing clothes at once, like ironing clothes, all the clothes at once, without like have intervals, right? Okay, those are like, anyway you can remember that, those things. So you have learned those things in grade 6 or 8 also, right? So that's enough. Then the last part, safety precautions when following when using electricity. So that one you can try to complete. I'll give this for homework next week. I'll use the pencil and try to complete this without my help, because I have explained all this. 18th one you can do for homework. If you have a doubt, you can fill with the blank, the pencil, and next day I'll give the answers for these 7 blanks. This is for homework. Sometimes I might discuss this tomorrow. You can see now, today I discussed, this is how 2017 OL paper, they have asked questions here. They have got a set of electrical appliances and they are asking which one 3-pin plug, which one convert, like that. They have, it's a good question. So tomorrow night online paper class, sometime I might discuss this, right? Saturday night paper class, Saturday 8 p.m. paper class, I'll discuss this question, right? Please try to answer this before, because not much. So one essay type question, at least the first essay type question, at least the first essay type question, last question you have to answer at home before tomorrow night, right? Okay, it's almost 10 o'clock. We'll stop for today. Good night and God bless you.